Lesson 39, solving trigonometry equations. All right, so good news is we've actually done stuff like this in the past. So like in lesson 33, we would solve things, let's say like what is 2 sine theta, it's equal to 1, right? So what we do there is we divide both sides by 2. And then we're going to be asking, okay, where is sine theta equal to 1/2? So that would be at pi over 6. So theta would be pi over 6 and 5 pi over 6, okay? And then it would keep on doing that, right? So this would be the answer if it was between, let's say, 0 and 2 pi. But then we could also have a general solution, right? So anyway, the idea is we've already done stuff like this before. Now what we're going to be doing is just making it a bit more complicated, right? So in the last lesson, we learned all those different trig identities. So we can start to bring those into it. And then as a final, at the end, we can figure out what the angle must be once we've isolated for either like sine theta or cos theta. So if we're looking at this problem, right, I want to get it so it looks more like, come on, like, this situation where we had sine theta is equal to 1/2, right? So I want to just play around with this thing so that I get something that looks like that, or cos theta, or just something that we understand. Because right now I got this sine, or this cos 2 theta going on. I don't really know how to handle that very well, right? So what I'm going to do here is I'm going to start my journey where I'm going to, look at this cos 2 theta and see if I can turn it into something a bit more like sine. Okay, so let's go over here. I know I'm going to be looking down here at these 3. And then, I could change it into this one. I could change it into this one, but that's not really changing or helping me, is it? So I'm thinking, what about this one? What if I change cos 2 theta into 1 minus 2 sine squared theta? So let's try that. Oh, wrong one. Okay, so this will become, instead of cos 2 theta, this will be 1 minus 2 sine squared theta. And then we've still got, I'll make this a different color maybe, just trying to be fancy, minus 2 sine theta is equal to -3. Let's make it green there just to show that that was the one I actually replaced, right? So now this one's looking a little bit better, right? Maybe you don't see it yet, but it is looking better because now if this was like an x, x squared, and this is like an x, I think you guys would know how you would go about solving that, right? We have an x squared term and an x term. I think we need to get everything over to one side and have 0 on the other, and then we can factor this thing. Okay, so let's do that. So let's get... So I'm just going to put my x squared term first here. So this will be -2 sine squared theta, and then minus 2 sine theta. And then if I combine the 3 and the 1 on this side, those will become 4. And then that's equal to 0. Okay, so that's looking pretty good. Now, I think our life can be a little bit easier if we factor it out at 2. And I'm going to factor out a -2 just to keep this sine squared theta positive. So this will be -2, and then sine squared theta, and now this is plus 2 sine theta, and then minus 2. Nope. Plus sine theta now, because I factor the 2 out, and then minus 2 is equal to 0. Okay, so now let's factor the part in brackets here, right? So this -2 just hangs out, and we would have, well, this would become sine theta minus 1, and then sine theta plus 2 is equal to 0. Okay, and then now this one's actually just set up. It's just like what we did before, like in the other lessons, where I can look at these individually, right? So I can look at this one and say, okay, for this one, in order to make this equal to 0, right, because that's what I want, because I want this to be equal to 0 to make this a true statement. So I would say, okay, in this instance, sine theta would be equal to 1. So that's really where I'm asking, where is sine theta equal to 1? So where is my y equal to 1? Well, that's going to be at an angle of pi over 2. Okay, so now at this point, I could make a general solution. Like I could say, it's going to be pi over 2, and then it's going to be plus 2 pi n, like doing the general one so it works every time. But let's do this one too, just to make sure that, we can't combine them, right, and make another one. Well, if you put in, where is sine theta equal to negative 2? Well, you actually get an error. Like, that's not going to work, right? And one way of thinking of that, too, is that sine theta is equal to opposite over hypotenuse, right? And your hypotenuse should always be longer than your opposite side in a right angle triangle. So you'd never get a number that was really bigger than 1, right? So that's never going to work out in that case. Okay, so you end up getting an error. Okay, so then this is our only solution is on this side. So then we can make a general solution of this. So let's say, therefore, theta would be equal to pi over 2 plus, and then this is where we're going to tell it how many times to spin, right? So it's going to be spinning every 2 pi times n, where n is a member of the integers. And there you go. That's my general solution. Okay, and what we're going to do, I'm actually going to do one more too, because I've never made it onto the list, but it's kind of can be a tricky little one that might catch you. So here, let's do one over on the right here too, since we got the room. So let's do 4 sine theta cos theta is equal to 1. Okay. Now, why I was saying this is a tricky little one is because I'm looking at this. Okay, sine theta cos theta. So I look over at my sheet, and it looks a lot like this one, right? But this is 2 sine theta cos theta. And this is, for some reason, this is always one that throws everybody off. I can turn this into that pretty easily, even though it's a 4, by just writing it a little different. Why don't we write it like this? It'd just be 2, and then times 2 sine theta cos theta is equal to 1, right? So we just split that 4 up as 2 times 2. Okay, so if we do that, now we can say, okay, now what we have left would be 2, and then 2 sine theta cos theta was sine 2 theta. Is equal to 1. Okay, and then all I'm going to do here is I'm just going to divide by 2. So we're really asking ourselves, where is sine 2 theta equal to a half? Okay, and now the way to handle this too is, now just picture for a second that this is one thing, right? We're saying sine of an angle. Just don't worry about the 2 for a second. So this is like big theta, or maybe x or alpha or something like that. Okay, now just do it like normal. Where is sine of alpha equal to a half? Okay, well that was actually the same as the last one, wasn't it? Oh no, that was the one I did above. So let's do this in degrees actually, just to keep things simple. Okay. Okay, so if we're doing that's going to be at, so where is this going to be for alpha, let's say, or 2 theta? We could say 2 theta would be equal to, and then wherever that's the sine of 2 theta is equal to a half, so that's going to be at 30 degrees, and at 150, and at 390, right? 360 plus 30, and then I'm just trying to show the pattern here, and then 510. Okay, now that's what 2 theta is, right? So if I want theta, well, can you see that I could just like divide everything by 2, right? Because I divide 30 by 2, so all of these would just end up being like divided by 2 in the end. So you get, my angles are really going to be like 15, 75, 195, 225. Okay, so then in this case, since we have a two angles that like you're going out in quadrant 1 and quadrant 2, we got to make 2 different solutions here because they don't really line up nice. So I'll say theta 1 in general solution would be 15 degrees plus, and then look what my pattern is now, right? So it's like goes 15, 195. Okay, so that's actually just 180, right? So it's going to be 15 plus 180 n degrees n, where n is a member of the integers. Okay, and then theta 2 we just do it for 75. So then now it's going to be 75 degrees plus 180n, where n is a member of the integers. Okay, so those would be my two solutions there, right? All right, moving on. Okay, so for B, I'd like, again, to combine these things into, you know, just sine or just cos or just, well, maybe tan. But let's see what we can do here if we just rewrite tan as sine and cos. Maybe that'll make things nicer. So I can rewrite this now as sine squared theta is equal to sine theta over cos theta times cos theta, which works out nice. I can cross those out, right? And then at this point, well, all we're going to do is just get sine squared theta and sine theta on the same side. So we'll say this is sine squared theta minus sine theta is equal to 0. Okay? So this is like x squared minus x is equal to 0, right? Now let's just factor out one of the signs there. So this would be sine theta times sine theta minus 1 is equal to 0. And now I can see what my solutions would be, right? So I'm going to be asking, where is sine theta equal to 0, right? That's going to be for this solution. So where is that equal to 0? Well, that's going to be at 0 degrees, and that's going to be at 180 degrees, and 360, and so on, right? Okay, so I'll just leave that for a second. Maybe I can combine these into one. Okay, and then this one will be saying, where is sine theta equal to 1? Okay, so that is going to be at an angle of 90 degrees and 270 degrees and so on, right? Now, before we get going, one thing we probably should have done right off the bat was figure out what our solutions can't be, right? What are the solutions that aren't allowed, right? What are our MPVs from really when we were dividing by cos to begin with? Okay, well, in that case, our MPVs would have been angles of, well, what would make cos equal to 0? Well, that would be at 90 degrees, you know, plus 180 n, where n is a member of the integers. Okay, so those aren't allowed, right? So that's exactly, it looks like, what we have going on here. That's the same thing. So these are actually extraneous. So those aren't going to count, right? So very tricky place, right? So just remember that we want to always make sure we figure out our MPVs before we make our final solution here. So in the end here, it would just be based on these numbers. So our angle, our general solution, would be 180 n plus n, where n is a, oh no, comma, n is a member of the integers is all we needed there. Okay, next one. Sorry, I'm going to erase this one, guys. If hopefully you wrote it in a better spot than me. All right, so looking at this one, so we got secants now. So this one actually looks pretty good to actually factor just the way it is. Maybe we should actually just factor now and then do some flipping after. You know what I mean? Like instead of writing it as 1 over cos now, because yeah, I can probably separate it out pretty well. So let's bring this 6 over. So we'll write this out now as secant squared theta plus 5 secant theta, and then plus 6 is equal to 0. Okay, and then we'll just factor like normal. So now what we've got is secant theta plus 3, and then secant theta plus 2 is equal to 0. Okay, now let's make like a little expression for each of these. So for the first one, this would be, where is secant theta equal to -3? Okay, and I'll just do this one first, and then we'll move on to the next. So now at this point, this is probably where I want to flip it, because that's kind of hard to picture, right? I'd rather think about it the other way. Let's figure out where is 1 over cos theta equal to -3. Which would be the same thing as saying where is cos theta equal to -1/3 if you just flip that all around, right? Okay, now this one doesn't look familiar, right? This isn't something like on our unit circle. So in this case, all we have left to do is just to put this into your calculator. And we want to do this in degree mode, so make sure your calculator is in degree mode. So we would just write out theta is equal to, and then cos -1 of -1/3, which is equal to 109.5 degrees. All right, now I wish I would have wrote a little bit smaller now, because I just kind of want to explain this part now. Like what does your calculator actually do? So I'm going to steal this space here, and then I'll do this one over to the right more when we get to it. So what we're looking at here, what your calculator told you when it gave you that number, right, is, well, let's think about this case too, right? When we were looking here, we could use our cast rule. And we're going to ask, where is cos negative, right? So cos is negative here and here. So this will actually kind of work out. A number like 109, what that's doing is that's actually giving you the angle from the positive x-axis to the first terminal arm, right? So that's what it's doing. It's figuring out from the positive x-axis to there. So that's what that first angle is of 109.5. But we need to remember that there's actually two angles involved here, right? There's going to be that one, but then there's also going to be this angle. Okay, there's two that are coming up from this, from doing this. So how am I going to figure out that one? Well, first step is to figure out what our reference angles are. Okay, because those would both be the same. So what I'm going to do here then is I'm going to go 180 minus 109.5. Okay, so 180 minus 109.5 is 70.5, right? So that's what this is. This is 70.5 degrees. Okay, so if I want the second angle, right? I'll just draw it in here one more time. I'm getting a little bit kind of messy here, but that angle, then that's going to be 180 plus 70.5. Okay, so that's going to be our second angle, would be 180 plus 70.5 is going to be 250.5. Okay, so that's our second angle right there. Okay, so here, just to summarize that, we'll say angle 1 was equal to 109.5, just the one we found there. And now I know that this thing is going to be, plus 360, every time all the way around, plus or minus 360. I'm just going to leave it like that for now, and then I'm going to put it all together at the end. Okay, so that's my first angle. My second angle there was 250.5. Okay, so I got those two down. So we've done this one. Okay, so now we need to look at this one. So we'll do the second part of this. Okay, like I said, I hope you guys found more room than me. Okay, let's go with this one. So now we've got, where is secant theta equal to -2? All right, so then this would be 1 over cos theta is equal to -2. I should write smaller. Okay, from now on I'll write smaller. 1 over cos theta is equal to -2. Okay, so this is really saying, where is cos theta equal to -1/2? Okay, so that would be, this one's a bit easier because it's on your unit circle, right? So this would be at angle, here, let's go angle 3 now, because I did 1 and 2. So angle 3 would be at 120 degrees, right? This is just looking off your unit circle, right? The x value at these angles. And then angle 4 would be at 240 degrees. Okay, and these angles I did so far, those were just between 0 and 360 degrees, right? So now I need to make a general equation actually for all of them, right? That actually just includes everything. So let's one by one, right? They actually all have to be done individually because there is no great, there's nothing that connects them all. So angle 1 would be 109.5 degrees. So this one. And then plus 360n, where n is a member of the integers. So just 360 degrees, right? Adding or subtracting that. Angle 2, so this one will be our next one. So that's going to be 250.5 plus 360n, where n is a member of the integers. Angle 3 would be 120 degrees plus 360n, where n is a member of the integers. And then angle 4 would be 240 degrees plus 360n, where n is a member of the integers. And that is our solution. That's probably the longest solution you've ever seen, right? But that would be the solution for like all of the solutions for that. Okay, next one. Okay, cos to the 4 theta minus sine 4 theta is equal to 1. Okay, so now in this case, what we're going to do is I'm going to factor this again, right? This is a perfect square, and so is that. So we can make this a difference of squares. Okay, so the other thing I was thinking about this now that you could do, you could rewrite this as well as cos squared theta times cos squared theta, and then use your identities, right? Because cos squared theta is really 1 minus sine squared theta from this one. And you could do it that way too. So like I was saying in the last lesson there's many ways to do these. But I am going to factor this, right? So we're going to do a difference of squares. So this would be, I'm going to give myself more room this time, cos squared theta minus sine squared theta. And then cos squared theta plus sine squared theta. All right, and that's all equal to 1. Okay, so now good news is this is just equal to 1, right? So that just gets canceled out, or it's just equal to 1. And all we have left now is just this part. And I can simplify that too, right? Cos squared theta minus sine squared theta is this, right? Cos squared theta minus sine squared theta. So that's just equal to cos 2 theta. So this is equal to cos 2 theta. Okay, so this whole thing just became, where is cos of 2 theta equal to 1? Okay, so we're saying, where is cos 2 theta equal to 1? Okay, so 2 theta then would be equal to, and I'm just really saying where is cos equal to 1 here, right? So that would be at 0 and 2 pi, right? And 4 pi, right? If you kept on going around. Okay, so those situations. So now, really what I'm going to do here then is just divide everything by 2. Okay, and that's where theta would be. So theta would be equal to still 0, and then pi, and then 2 pi. Okay, so this is what our actual pattern would be for theta. So now let's write out a general equation for that. That would be theta is equal to, and then I can't use 0 because that would just wreck it. So I'm going to start out with pi times n, where n is a member of the integers. All right, moving on to the next one. So sine 2 theta is equal to negative root 2 cos theta. Okay, so this one, I just kind of weigh my options here, and I'm like, okay, I could rearrange this thing. It's not going to do anything. You know, I can't really change that cos into much, you know, like simply. But one thing I could do, right, this sine 2 theta, I could play around with that a little bit, right? So sine 2 theta, what's the equation for that one? So sine 2 theta, I could rewrite it as 2 sine theta cos theta. So I'm going to write this as 2 sine theta cos theta. Okay? And that's equal to negative root 2. Okay, so now that you have it written out this way, your first instinct here might be to do this. You might say, oh, cool, we get to cross out our coses, right? Because if we divided both sides by cos theta, they would disappear. That's actually not going to be an option for us. And it would be for the same reason that, well, here, I'll give you a little example. If I had x squared is equal to x, right? And I want to solve this one. Well, you could just, cancel one of the x's with the other side, right? And then x would just be equal to 1. But what we should do here is you'd bring x to the other side, right? You have x squared minus x is equal to 0. And then we factor out an x, so you have x minus 1 is equal to 0. And we see that if we would have just canceled that, right, we would have forgotten about the answer of 0 being involved here as well, right? So we can't just cancel that out. We have to include that, right? So when you cancel it out, you're actually canceling out one of your answers. Okay, so looking back over here, what we're going to do then is we're going to get everything over to that side, okay, and have it all equal to 0. So we'll have 2 sine theta cos theta, and then plus root 2 cos theta is equal to 0. And now, just like in the last example I did with the x's, I'm just going to factor out my cos theta. So now we're going to have cos theta, and then start my bracket, and then write what we have left. So then that's going to be 2 sine theta plus root 2 is equal to 0. Okay, so now we can see this a bit more clearly, right? Now I'm looking at this as one of my answers, and I'm looking at this one as one of my answers. So cosine theta, so I'm saying where is cos theta equal to 0? Okay, well that's going to be equal to 0 at angles of pi over 2 and 3 pi over 2, right? So like in steps of pi over 2, right? Okay, so that's my first one. So now I look at my second one. So I'm saying where is, and if you did a little bit of algebra there, right, this would be the same thing as sine theta. Well, here, let's actually, just so you can see what I'm doing, let's write out 2 sine theta plus root 2, and I'm making my own little equation, right, like making that equal to 0. So in the end, solving for sine theta, we would have negative root 2 over 2. Okay, so where does that happen? So root 2 over 2 is on our unit circle, right? And that's going to happen at angles of 5 pi over 4 and 7 pi over 4. All right, so now all that's left is just to make our general equation out of this, right? So let's do it for the first one, because in this case, I'm just going in steps of pi over 2. Okay, so in this case, we're going to have angle 1, we'll say, is going to be pi over 2 plus, or sorry, not steps of pi over 2, it's in steps of pi. Sorry, guys. So pi over 2 plus pi n, where n is a member of the integers. Okay, so that's going to be that for that first one. Okay, so there's one answer. Now for the second one, 5 pi over 4 and 7 pi over 4. All right, 5 pi over 4 down there, and 7 pi over 4 is down there. There's not a great way to combine those two, so I have to handle them individually. So I'm going to go 5 pi over 4 and then, go 360 around to that one again. And then this one, 360 to get to that one. So they have to be done on their own. Okay, so just, angle 2. So I'll do the 5 pi over 4, so that'll be 5 pi over 4 plus 2 pi n, where n is a member of the integers. Okay, and then just one more. So angle 3 would be 7 pi over 4 plus 2 pi n, where n is a member of the integers. Okay, so now what we're going to be doing is solving these things, but using a domain to restrict our answers. And then just with a specific example of having a multiple angle, so it just looks something like this, right? 2 times the angle or like in this case, it'll be like 1/2 times the angle. Yeah, so I'll show you. We're going to solve just like we were, but I always have to be careful with our answers. So this one says find the solution for this, and the angle is restricted between 0 and 2 pi. Okay, and just take note of that, how this one is greater than or equal to 0, and this one is just less than 2 pi. So if you get an answer of 2 pi for one of your angles, then that's actually not an angle, right? Because it has to be less than 2 pi. Okay, so just careful on those. All right, so let's get going on this. So now, to begin with, if this is our domain, right, then what we can do is say the domain, just like our temporary domain here, right, for 2 times the angle, right, would end up being, well, 2 times what we had going on there, right? 2 times, theta being greater than 0 and less than 2 pi. Okay, so our new domain here is going to be for 2 times the angle is going to be from 0 and less than 4 pi. So why that's useful is when I actually solve this thing, I'm going to get all the answers in this domain. Okay, I'll show you what I mean. So if we solve this, then we're just looking for where is sine, right? And just call this, the whole thing, just imagine that's just theta for a second. Root 3 over 2. Okay, well, that's going to happen. So I'd say 2 times the angle, right? 2 times the angle is going to be equal to, well, this would happen at pi over 3. And then it's going to happen again at 2 pi over 3. And then again at 7 pi over 3. And then again at 8 pi over 3, right? And now, why I wrote them all down, right, is because I'm just getting all my numbers between 0 and 4 pi, because normally I would stop there, right, because that's before 2 pi. And then now this is right before 4 pi. Okay, so those are all my answers. And then lastly, I'm just going to divide everything by 2. So divide by 2, all the way around. So we get the angle is equal to pi over 6, and then pi over 3, and then 7 pi over 6, and then 4 pi over 3. Okay, so those are my answers, and just double check, these are within this domain. All right, now solve this one. So again, let's set up the domain just to kind of help us out here to know what we're after. So the domain is between 0 and 2 pi, again, right? Just written in the other form there. So domain, we're going to say is going to be 1/2 of that. Okay, so the domain I'm going to look for first would actually be the domain from 0 to pi. It's going to be more useful, right? Okay, so now I'm just going to ignore the stuff in the middle and just look for where is cos equal to negative root 2 over 2. Okay, so that's going to be, so we'll write down, 1/2 x is equal to, so again, I'm just looking for where cos is equal to negative root 2 over 2 right now. And that would be at 3 pi over 4. Okay, and then I'm going to stop there, right? Because I'm restricted by this domain. Okay, so this happens in quadrant 2, and then it would happen again in quadrant 3, right? That would also happen at 5 pi over 4. But I'm not going to include that one because I'm being restricted by this first domain and just a pi there. Okay, so I'll just leave it like that, and then now I'm just going to solve for x. So there's only that one solution, and then we're just going to multiply both sides by 2. Okay, so multiply by 2, and also multiply this by 2. So we get our angle x would be equal to just 3 pi over 2. And that's it. That was just our single solution in that domain. All right, next one. Solve root 3 tan 3x minus 1 is equal to 0, where x is greater than or equal to 0 and just less than 2 pi. Then write the general solution to that same expression. Okay, so again, writing out our domain to figure out what we need to solve for here, we're going to say the domain would be 3 times the domain they gave us. Okay, so the domain we're actually looking for here is going to be, like to begin with anyway, is going to be 0 and then 6 pi. So we go all the way up to 6 pi for the first one. All right, now I'm going to do a little bit of rearranging here now. So I'm just going to write this out one more time. So we've got root 3 tan 3x minus 1 is equal to 0. Okay, so I'll add 1 to both sides and then divide by root 3. So we've got tan 3x is equal to 1 over root 3. Okay, now I'm kind of thinking on the unit circle, where is it 1 over root 3? And it'll actually be a little bit easier, I think, to maybe think about it as, well, if I rationalize the denominator, right, multiply top and bottom there, this would be tan 3x is equal to root 3 over 3. Okay, so where is that going to happen? That it's equal to root 3 over 3? So let's look at the unit circle here quickly. So that would be, well, really here, right? Because that'd be a place where we have 1/2 divided by root 3 over 2, right? This is my y over my x, right? Because I'm doing tan, so it's like y over x or sine over cos, right? So if you do that, that ends up being 1 over root 3, which really was our answer. Maybe it would have been easier to leave it that way. But then if we rationalize that as well, we get root 3 over 3, right? So it's going to be there. And then the other place that happens. So that will be down over here, right? Where we have a negative over another negative, right? To make it positive. So it's going to happen at pi over 6, and it's going to happen at 7 pi over 6. Okay, those are the two. Okay, so then here I'll start up here. So tan 3x, I'm just going to write 3x is going to be equal to, okay, now I got to keep going around all the way until I get to 6 pi, right, to make sure I get all my answers. So this is going to be 3x would be pi over 6, and then it would also be at 7 pi over 6, and then at 13 pi over 6. Okay, and maybe I'll just kind of stop there too and show you how we can add these up kind of quicker too, right? So notice what we had going on there when you were looking at your unit circle, that it was here and then it was also down here, right? So what we're doing is we are adding pi every time, okay? And now just in the case we're looking at here, they're over 6, right? So what might be useful, is to go like, so we're adding pi, but it might be more useful to think about adding 6 pi over 6, right? So notice the pattern here that we're going like 1 pi, 7 pi, 13 pi. We're adding 6 every time, but keeping the denominator the same. Okay, so that's just kind of what I'm doing here to do them quick. So okay, so 13 pi over 6, and then we're gonna have 6 more, so 19 pi over 6, and then 25 pi over 6, and then 31 pi over 6. And okay, just to make sure I'm in the right spot here, I can't go past 6 pi. So what we can do is go 31 divided by 6 and make sure that I'm not over 6. And yeah, I know I'm not. I'm at like 5 point something, right? Because 36 over 6 would be 6 pi, right? So I know I'm less than that, okay? So there you go. There's all of my solutions to 3x. But now I don't want 3x, I want x. So I'm just going to divide everything by 3. So divide by 3. And then I'm just going to do this and say divide it all by 3. Every one of those. Okay, so then we'll have x is equal to, so this would be pi over 18, 7 pi over 18, 13 pi over 18, 19 pi over 18, and 25 pi over 18, sorry, one more, 31 pi over 18, right? Now, notice what's happening here is that we're actually just going to be going up by 1/3 pi every time. So this would be like going up by pi over 3, and then up again by pi over 3, right? For every one of those. Okay, so anyway, that's our answer. And we'll just make sure that it falls within like the true domain, like our original one. So we just want to make sure, is 31 over 18 actually going to be less than 2? Well, yeah, because 36 would be, like 36 pi over 18 would be 2. So I'm less than that. So good, I'm within my domain there. Okay, now it says, it also says then write the general solution to it. So the general solution means that we don't care about the restriction anymore. So this would be the solution with our restriction that they gave us. And then the general solution would just be x is equal to pi over 18. And then, like I said, we were going up by pi over 3 in every one of those. And if you were unsure about that, how could you figure that one out? Well, you could do this. You could just subtract them, right? I could go, okay, 7 pi over 18 minus pi over 18. So that would end up being 6 pi over 18, which is the same thing as pi over 3, right? So that's what the gaps are here. So pi over 3 all the way up. So it's going to be pi over 18, my bad, plus pi over 3 n, where n is a member of the integers. So there's our general solution. All right, and then the good news is we already did this one. That's the one I wrote up above. It just fit more with the questions above, so we did that one. So yeah. So that's it. That's the end of the course. Give yourself a pat in the back. You guys did it. It's a long year. Well, I guess you do have to do the questions, and then you do have to do the final exam. So I guess that's not the whole year, but that's it for me teaching stuff anyway. So